Hi, I'm Mr. Parker and this is question 8 on the OCR Core 2 paper from June 2014. For more questions on this exam paper, click the link here or check in the video description. In part A, we're told the first term of a geometric progression is 50 and the common ratio is 0.8. Use logarithms to find the smallest value of k such that the value of the kth term is less than 0.15. Over here we've got the formula for the nth term of a geometric progression. Looking at the information given in the question, we're told that the kth term has to be less than 0.15. That means that un, or for the kth term uk, must be less than 0.15. We're also told that the first term is 50, so a equals 50. We're told that the common ratio is 0.8, so r is 0.8. And this is for the kth term, so instead of n here, we're going to have k. So let's substitute the values in and see what we get. On the left hand side, we're going to get 0.15 must be greater than this expression with the values substituted in. So we get 50 multiplied by 0.8 to the power of k minus 1. From here we can divide through by 50. And that gives us 0.003 on the left hand side. On the right hand side we're left with 0.8k to the negative 1. At this point we can take logs of both sides. So I'm going to take log of base 10. It doesn't really matter what base you choose though for this question. So I get log 10 of 0.003 equals log 10 of 0.8 to the power k minus 1. Next up I'm going to use the power rule for logs to rewrite this right hand side. So bringing the power down, I get k minus 1 in a bracket multiplied by log 0.8. For the next step, I'm going to divide through by log 0.8. So I'm going to get log of 0.003 divided by log 10 of 0.8 is less than k minus 1. Notice that the inequality here has switched directions. And the reason for that is that if we do a log of 0.8, you'll notice it's negative, and that's because log of anything less than 1 will be negative. Log 1 is 0, remember. So if we're dividing by a negative number, the laws of inequalities say that we need to flip the inequality sign over. So that's why here we've got a greater than sign and it becomes a less than sign here. Finally, to isolate k on its own, I'm going to add 1 to both sides. So I get k is going to be greater than log 0.003 over log 0.8 plus 1. If I now substitute this into my calculator, I get that k must be greater than 27.03 and so on. However, k is what number term we're on, and that means it must be a whole number. And if k is greater than 27.03, the smallest value that it can actually be is the next number up, which means that k equals 28. Part B says that in a different geometric progression, the second term is negative 3 and the sum to infinity is 4. Show that there is only one possible value of the common ratio and hence find the first term. So here I've got my formula for the nth term of a geometric progression, and here I've got my formula for the sum to infinity of a geometric progression, both given in the formula book. Notice here, we're going to use this later, that to use this formula, the absolute value for r must be less than 1. That means r must be between negative 1 and 1. So let's use these two formulae to form a pair of simultaneous equations. In the question we're told that the second term, so we'll call that u2, is negative 3. At present we don't know what the first term is and we don't know what value r is either, but we do know that n is 2. This gives us enough information to form our first simultaneous equation. We're going to get negative 3 equals a multiplied by r to the n minus 1. Well, if n is 2, this becomes 2 minus 1, so we get r to the power of 1, or just r. So we get negative 3 equals ar. I'm also going to rearrange this so that it says r equals by dividing through by a. And the reason for that will be clear later. If you didn't spot that you need to do that straight away, you probably would do later on when you formed your second simultaneous equation. For the second simultaneous equation, I'm going to use the sum to infinity. We know the sum to infinity equals 4, so s infinity becomes 4. Again, a and r are unknowns, so we can form a simultaneous equation that says 4 equals a over 1 minus r, and I'm going to call that equation 2. Now the reason I rearranged this first equation is because I can now substitute number 1 into number 2, and that gives me 4 equals minus 3 over r divided by 1 minus r. So we've got a complex fraction here where we've got a fraction inside a fraction. Now if you don't know how to deal with these, I'm going to link to a tutorial where you can look at that in more detail. But in order to answer this question, I'm going to assume that you've seen a fraction like this before and just talk through it briefly. So the first thing I'm going to do is turn this into a 4-layer fraction. I'm going to have 4 on this side still, and I'm going to leave the minus 3 over r as it is. But I'm going to write 1 minus r as 1 minus r divided by 1. And the rule for dealing with a 4-level fraction is you multiply top and bottom together. So negative 3 times 1 is negative 3, and you multiply the two middle terms together, which I'll write using brackets to start off with. Next, I'll expand out this bottom line, so I get 4 equals negative 3 over r minus r squared. From here, all we need to do is rearrange and solve the resulting quadratic. So multiplying up by the bottom of this fraction gives us 4 lots of r multiplied by 4 lots of r squared. On the right, we're left with negative 3. And if we move the two terms on the left-hand side over to the right side, we get 4r squared minus 4r minus 3 equals 0. Let's check whether we can factorise this using the discriminant. So a is 4, b is negative 4, and c is negative 3. So b squared minus 4ac becomes negative 4 squared minus 4 times negative 3. Negative 4 squared is 16. And 4 times 4 is 16, times negative 3 is negative 48, so we're subtracting negative 48. Altogether, that gives us 64. Because 64 is a square number, that tells us this quadratic should factorise quite easily. So to factorise it, I'm going to use the AC method, which means I'm looking for two numbers which multiply to give a times c, which in this case is negative 12. I also want two numbers that add together to give b, which is negative 4. And the numbers I'm looking for are negative 6 and 2. Next, in order to form my factorised expression, I'm going to put 4r into both brackets. Now, I know expanding that out would give me 16r squared, but we'll deal with that in a minute. For the other term in each bracket, I'm going to have negative 6 and plus 2. From here, if I can cancel a common factor out of either of these brackets, that's what I need to do. So there's a common factor of 2 in this first bracket, so dividing by 2 gives me 2r minus 3. There's a common factor of 2 in the second bracket as well, so dividing by 2 gives me 2r plus 1. And if you expand that out, you would find that you get the quadratic that we're trying to solve. So for my next line of working out, I get 2r minus 3 in one bracket, 2r plus 1 in the other bracket equals 0. Don't include this in your working out, because technically this line with the 4r on doesn't strictly follow from this line here, so we shouldn't really have it in our working out. Now that we've factorised this quadratic, it's fairly easy to solve. For the first bracket, we get 2r minus 3 equals 0. Adding 3 and divided by 2 gives us r equals 3 over 2. Or we could have 2r plus 1 equals 0. Subtracting 1 and dividing by 2 gives us r is negative a half. So we've currently got two values for r here. But it says, show that there is only one possible value of the common ratio. And if we go back to the previous part, where we look at the formula here for the sum to infinity, it says the absolute value of r must be less than 1. That means we can rule out this solution here with r equals 3 over 2, because that wouldn't give us a sum to infinity which converges. So we can say, since the modulus of r has to be less than 1, the only possible value for r is when r is negative a half. And we also need to find the first term. So if we go back to our previous page and look at our initial simultaneous equations, we've got minus 3 over r equals a. So here, when r is negative a half, we can say a equals negative 3 over negative a half. Well, 3 divided by half will be 6, so negative 3 divided by negative half should also be 6. So we've only got one possible value for r, that's negative a half, and when r is negative a half, the first term is 6.